Okay, so this next one's a really interesting question, and they don't very often come up in GCSE. So we've got a box, and they ask you to find the maximum volume. Now, what you need to be thinking is, if it's near the end of a paper, and they're asking for the maximum volume, or the maximum height, or the maximum area, you need to be thinking differentiation. So the volume, let's firstly set up an expression for the volume. The volume is going to be 15 minus 4x multiplied by x multiplied by x, which when you do it fully gives you an answer of 15x squared minus 4x cubed. And so what we need to do now, we want the maximum. So if we differentiate this and set it equal to 0, that is how we will find our maximum. Because basically, if you take all the dimensions that you could possibly have for x, they would form a curve like this. Okay, because that's how it would look. Or it forms some form of curve. And we want the maximum point on that curve to give us the maximum volume. So what we're going to do now, we're going to say dv by dx is equal to 30x minus 12x squared, and that there is equal to 0. So what we'll say now, 30x equals 12x squared, and so now taking it from there, we're going to cancel 1x from this side and the squared part from this side. So 30 over 12 is equal to x, and 30 over 12 is the same as 2.5 or 5 over 2. So now what I'll do, I want to find the maximum volume. So I now take this number, this 5 over 2, and I plug it back in to here. So what I'm going to do, my maximum volume, I'm going to call it Vmax, is equal to 15 multiplied by 5 over 2 squared minus 4 times 5 over 2 cubed, and that gives me 31.25 centimetres cubed. Now be really careful with your units, don't forget about them. And there we go, that's our final answer.